A very special and warm welcome to all our guests present today. I'm Salomi Thakur, Assistant Project Manager at Cloud Counselage Pvt Limited, and I welcome you all to this webinar, Hello Machine Learning and Deep Learning. The agenda for this webinar is as follows. First, we'll know about Cloud Counselage Pvt Limited, that is CCPL, and Cloud Counselage Gifter Career Foundation, CCGSE. After that, we'll try to know about the guest speaker a bit more for today's event. Once we know about him, we'll try to understand what is machine learning and deep learning. Lastly, we'll have the Q&A session. So for all the guests present today, I'm sure we must have interacted before through various other events held by Cloud Counselage Pvt Limited. But for those who are new and are engaging with us for the first time, we would like to walk you through who we are and what we are trying to do. So Cloud Counselage Pvt Limited is an IT and management consulting and advisory company with a social cause at heart of helping the students community. We are based in Mumbai and we are on a mission to build IT and management capacities pan-India. With respect to our services, our major services are consulting and advisory in the domains of IT and management, wherein we leverage the latest technologies to help the businesses. We also have our own products, and we are very proud to say that our interns also contribute towards building these products. We have various programs to support the academia as well, namely the IAC, that is Industry Academia Connect, and the IAC CCPC, that is Industry Academia Connect Cloud Counselage Professional Community, which gives insights on the latest technologies, best industry practices, etc. We'll let you know more about this in some time. We also have a cloud store to add value to our cloud businesses and our partner businesses. Cloud Store provides varieties of solutions that include servers, learning management, hosting, workspaces, etc. We have catered to multiple industries like fintech, technology, FMCG, IT, banking, and infrastructure. In terms of our workforce, we have a workforce spread across 6 countries, which includes our affiliates, our partners, our associates, and our interns as well. In terms of our journey, we started in 2015, where we registered as a private limited company with the Ministry of Corporate Affairs. Then in 2016, we were working and branding our services through various events. In 2017, we started taking consulting projects in London. And 2018, we worked on the flagship project, which had its operations spread across 120 countries. In 2019, we started to streamline our operations in India. This was also the time when our founder, Mr. Tushar Tupale, received the Star Alumni Award from his alma mater. That is when he realized that things have not changed much after almost a decade, and he remembered his struggle, which he went through to get his first good job. There were no campus placements or mentorship provided, and it all reminded him when he visited his campus. So he decided to do something for the student community as an organization, and that's when he initiated the Industry Academia Connect. To deliver Industry Academia Connect and to achieve this vision of helping the students community, we have established a foundation, which is a not-for-profit organization, which is called as CCGSE Foundation, that is Cloud Counselage Gifter Career Foundation. Through this foundation, we'll be helping the students to achieve their dreams vis-a-vis their professional life, and this we are going to do through our Industry Academia Connect initiative. Industry Academia Connect, or IAC, was also initiated in 2019, and we have participated in many events with the government bodies and with the universities. We have conducted various webinars and other events for the students, and along with that, we have onboarded 1,000 plus interns from across 150 colleges in Maharashtra. We want to help even more students pan India, and this is the second year, and we want to give more to the students community. So what are the activities that one can get to encounter through IAC, and how IAC through the Cloud Counselage professional community is going to help the student community? The intent of IAC-CCPC, which is Industry Academia Connect Cloud Counselage professional community, is to provide a platform to the young generation, the Gen Z of India, to participate with the industry. The essence of Industry Academia Connect is that it enables the complete Industry Academia Connect on one single platform. One such activity under IIC CCPC initiative is a monthly webinar or talks with the community. And one such professional we have today is Mr. Karthik Raj Naidu, who is currently a software development intern at ConnectWise. He has also been a Google AI Explore ML facilitator, where he delivered various sessions on machine learning under the Google AI Explore ML initiative. He has also been a student partner at Microsoft, where he has conducted various events on MS Azure and ML techniques. He is also good at Android development and has been a project trainee at the National Informatics Center. Mr. Naidu is also skilled in React and Python development. And at last but not the least, he has also been an intern at Cloud Counselage. Today, we have the honor and the chance to listen to him to understand more on the topic Hello Machine Learning and Deep Learning. Without any further ado, I would request Mr. Naidu to take over and explain us what is machine learning and deep learning. Over to you, Karthik Raj.
Yeah, thank you, Salome, for that great introduction. Let me just share my screen in a bit. I hope it's visible here. Okay, so hello, students. As Salome told, my name is Karthik Raj. I am an past intern for the Cloud Counselage, and I have been I have my passion towards machine learning and development in Android projects. So I hope this presentation will be a great introduction to you in this great field. So for my acknowledgements, I would like to thank the Cloud Counselage team for having me, and also I hope that the prerequisites like the basic maths are known to the students, and also they have the curiosity to explore this domain and to go further in their depth. So I hope yeah, like you are one of the people who think that AI, machine learning, deep learning are like the big words of the industries, and how can we get a start for it? So this entire presentation is focused on that you are not alone. There are many people like you, and I hope this presentation will be a great start to getting know about the field, and it will give a head start than the students which are still left in looking at the field around. So going for the agenda of the today, I will be covering topics like what is ML and how it's different from the normal programming, and what is the necessity of the ML and deep learning in this era. Then what is the difference between AI, ML, and deep learning, the different types of machine learning, and at the end I will be covering a brief overview about neural networks. So, before we enter the machine learning, if we read the machine learning from textbooks, etc., they will give us an definition a computer program which is said to learn from the experience respect to the class T and performance P and measured by experience. So this might be something like boring to you guys, right? So at the first slide, if I show to you this, it might be like overwhelming, and you will be thinking like machine learning is entirely a theoretical subject. So before we go to know what is machine learning, etc., first we have to understand the question that why we should use machine learning. So the first thing, like the we as a people, humans, we got bored writing the same code again and again. Like we write the code for the factorial of number right from 12th standard to the almost to the third year of engineering. We wrote the factorial of number in different programming languages. So I think I got bored with this. I hope you too. So like machine learning, we now make use of machine learning and make the computer write the code for us. So that would be really cool, right? Like computer can write the code for us, and we have to just sit back and watch. But later we found out that the computers were too dumb to understand. Like we can easily tell from an image whether it's a cat or dog, but from an image the computer cannot even know if it's an image of cat or dog, any human or etc. So that's why we had to go through the entire process of teaching the machine, which are basically simple for us. So as we do in our exams, whenever we come across a new subject, we have to go through the entire subject again, portion again and again, read it multiple times to get an good score in the exam. In the same way, the computers have has also to go has to go through the data which we are providing, and it goes through the data and again and tries to remember it. So, like before going like much deep into the machine learning, I like an quick demonstration like how machine learning can solve many complex problems. So this is an simple activity. You can go it as this in this link g.co/quick draw. Uh, so from this demonstration, like this is a demonstration where we can draw a doodle, like any drawing, like an clip art or something, and the program can identify which object we are drawing. So, for example, if we are going to draw a saw, um, yeah. So it So from a simple, like a simple doodle, machine learning can know it's a saw or something. It's easy for us to understand, but for the computer, like where everything is coded, you can draw like a saw in another format or something. It is very hard to understand for a computer from a simple doodle. So, like here is another example. So this is a very rough drawing, but even though from that the computer is able to understand it's a drawing of a spoon. So that's the precision of machine learning, how it can be flexible to understand from the multiple images that we provide, and it can help in the day-to-day life, our day-to-day life in many instances. So from this activity, like let's have a discussion that how does this game work? So in this game, like we are just drawing the things, but how the computer is able to understand whether I draw a spoon or it was just a handle or even a side mirror of a bike. So how can it understand from those different drawings? So the third most important question is how can we program this? So like if we wrote a program, like you might be knowing some basic programming in C++ or Python. So at that time, if I am giving you a drawing of the spoon, so how can we determine whether it's a spoon or not? So, like in the traditional approach, if we are used to have if we are given a end product and we have to first frame the goal like how we were going to be solving those problems. So first of all, like if we are going and program for detecting whether an image is a spoon, so we would develop the entire logic and develop programs for that. Like if conditions, like if the spoon has a long handle, if there is a round circular shape at the end, and if it's tapered, etc. So there might be if condition. So if I had drawn the spoon in the vertical position, then there should be a separate code for that too. So for an even single spoon, there might be hundreds and thousands of lines of code based on the different patterns and drawings of an image. Then too, it would not have been perfect. There might be some time where people have drawn spoon inside a bowl. At that time, it may give a large number of programs. So as you come to know that using the traditional approach like coding the entire thing and then checking whether it's working or not and then get back to coding and refining it. This entire process doesn't work for like these conditions like detecting spoon images or detecting saw images from the saw images. So here comes the part of machine learning. So in machine learning, we use a model. A model is basically a black box in which we just feed images, like the example images. Like for example, if we have to detect a carrot, so we feed multiple images of carrot, and the box or the model trains from those images. It learns like as you study like physics or mathematics. You solve multiple questions. You by heart those theory questions and and remember like what questions were from the behind and write the new answer from the paper. In the similar way, the model trains from the images which is provided and it learns the features. Like for example, if I want to remember a carrot, I will be remembering that a carrot is orange in color. It has a tapered end at one end, and it has some grass or green color grass on the top end. So this is how a model remembers. And once it learns from a single image, it goes to the next image and again until it refines the goal that are provided. So, if I were to explain like how the quick draw project was created. So the this project was done by Google, and they collected around 50 million drawings of each of those doodles. Like for example, here is an alarm clock. So you can see that there are so many images for alarm clocks, and the machine learning model which they have trained has been learning from each of those clocks. So once you have seen around 50 million drawings, you are able to identify, like most of the cases, you are able to identify whichever doodle you are drawing. So that's how like machine learning helps in solving the problems that are too much complicated when they are drawn with when they are tried to solve with the normal traditional programming. So, like these are some real life scenarios which we face. Like in the Spotify playlist, there are we have to sort the songs, like OLX house prices prediction, ranking the web search pages, and Snapchat filters. So these are the problems, and if we want to decide like which method should we use, should we use a normal computer program or should we use a machine learning? At that time, we have to think before we start with the development. Like for example, traditional programming for sorting the songs based on the playlist. We don't require any hardcore machine learning model like it can divide based on the user's preference, etc. We can just use an sort program and try to achieve it. But for predicting the house prices of OLX, we require the data from the past purchases. Like in an area, the OLX collects the data from all the houses and the prices which were bought, and that helps in prediction of the future cost of a house in a particular area. At that time, the machine learning helps to solve those problems. Also, while we use Snapchat face filters, at that time, from an image of our front camera, it is able to detect our facial features, and it helps to overlap the filters provided by the Snapchat to our faces. If we were able to trying to solve the Snapchat face filter by traditional programming, then we would have written like 2000, 3000 lines of code where we detect the eyes, we detect the mouth, we detect nose, and etc. So that will be very much complicated, and that would not have been accurate also because each of us have different facial features, different skin color, different like even the beard, hair, mustache, etc. And last, ranking the web search results. So I have put this intentionally in both of them because ranking search results in traditional programming involves searching how the content of the website is. Like for example, Wikipedia. If I want to search information on machine learning on Google search, it will provide the information from Wikipedia because Wikipedia has many number of words that are related to machine learning. So that's traditional programming, like counting how many keywords are there in each of those web pages. But when we go towards the machine learning ranking web search results, that comes like when we use the user's past history search. Like for example, whenever we go to Flipkart and search for a mobile, and then we go, it also recommends us the mobile cover case and the mobile screen guard because it has the history of users whoever has bought the phones in the near future, they have been buying the cover cases, etc. So that's ranking web searches to the machine learning. So just a basic recap of the things which we covered, like what is rule-based approach and the machine learning approach. In rule-based, we are focusing on the rules to be definite, where we hard coded those rules, like for a height of a person, weight of a person, etc. So in machine learning, we learn from the patterns of the data, we get the trends of the data, and these trends are able to predict whatever the future outcome will be, and it has the also has the flexibility in which it can also compare the images or the text, whichever data we are providing within the tolerable limits. In the rule-based approach, the improvement comes from algorithms and network. For example, if we want to write a program for factorial and we want to change those program to multiplication or any other program, we have to change the entire algorithm and create a new structure for the code. But in the form of machine learning, if I have trained a model to give the factorial of a number, then later I can provide the data which gives the multiplication of a number, and the machine learning model automatically trains to the new data. So each of them has their own benefits. It's our preview, like whichever places we want to use machine learning and we want to use rule-based approach, we have to first study that and then we should get towards the development. So I hope like how machine learning system works and how machine learning system is able to solve the real life problems which we face in nowadays. So for formally defining like what machine learning is, I can say that machine learning system takes an input or data from the user or from any other source to make the prediction and decisions about the unseen data. So, for example, if I give a image as an input of the data, it can do prediction and decisions based on those images, and those data need not to have been seen by the machine learning earlier. Also, it helps the computer to learn how to do a task without being explicitly programmed to do so. So that includes like if write programs for a robot to walk around a road, I need to if I had hard coded that if the road has any some other turns, the robot might get stuck. But while using machine learning, the robot can learn from its experience, and also it can make its own decisions, and it doesn't need to be programmed each and every time when it takes any new decisions. So heading over to the necessity of ML, like why machine learning and deep learning have been like most heard words in the recent times. So first is the infinite growth in scale of data. In nowadays, we take images, we take documents, even like writing the assignments of our college for in the work from home situation. We are writing the assignments and uploading the data to the cloud of the into the college server. So all this data gets stored in the format of text, audios, images, even the data from the sensors like the Tesla car and electric car, they have their sensors. All this data gets sent to the cloud. So this data needs to be processed by us before using it in any other application. So the human capability for processing the data has surpassed the needs. So for example, in today's world, around 2.5 quintillion bytes of data is created per day. So quintillion, I hope some of the guys might be knowing, but quintillion is around 1 quintillion is around billion GBs of data. So that's the scale of data that's getting created each day. And if we like hope to write a code for like processing even 1 GB of data within an half an hour, so for writing 2.5 quintillion of data, it's going to take forever, and that's just 1 day of data. In the second day, there will be more. So that has surpassed our capability. So that's where machine learning comes. It can learn from each of these big scales of data and create a program that can learn from the new experiences and create the decisions automatically. So, like many of us have been like wondering what is artificial intelligence, machine learning, and deep learning. We have heard those buzzwords, but we don't have conceptual clarity on each of those words. Everyone thinks that AI is somewhat as an a robot from the future like Skynet or etc. That is fully sentient, but that's not the case. Artificial intelligence is something where the machine learning model, the model or the computer can learn from the new experiences by itself. It doesn't need the new data to be trained, and it doesn't need to be hand fed by the user. It can do learn from by itself. That's the aim of the machine. Sorry, for the artificial intelligence. The subpart of the artificial intelligence is machine learning, where we provide the data to the model. It learns from the new data, and it creates the decisions or takes the decision from the data which has been learned from the past. So another subpart of machine learning is deep learning. Deep learning is somewhat of a recreation of the human mind. So how human think is somewhat reflected back in deep learning. We will be talking much about deep learning in the in the forward slides. So giving an clear differentiation between these three, artificial is intelligence is somewhat where we don't need explicitly to provide data. It can learn from its own and create the decisions. Machine learning is something that it can learn from the data which we provide, and it is going to take decisions from the things that has learned before. And deep learning is a subpart where the data is provided and it reads from again and again, and it takes the decision from that. So whenever we are hoping to use the machine learning in idea to a reality, these are the stages when we want to create a machine learning system. So for example, if I have to create a system for identifying like signal on a traffic jam, so, like first, I will be I'll be focusing on the user, which users I want to target, like the daily commuters or in an heavy traffic area, the people who break the signals. I would be focusing on the user. Second is the defining the objective. So, from using my machine learning model, with what I am hoping to achieve from our system is the define the objective. Like, should I catch the people who are crossing the signal, or the people who are in the bike who break the red signal, etc. Then the third part will be collecting the data. I will be collecting the traffic cam, CCTV images, for an day or and more, and collecting as much as data as possible. And the fourth system is training and testing the model. Training the model consists of feeding the collected data to the model and getting the model familiarized with the all the features in an image. For example, in a traffic cam, it will be able. We are training it using the CCTV. From CCTV camera, it can learn how the cars are moving at a particular signal time, and how the people are crossing during the walk signal or halt signal, etc. So this is considered in the training phase, and last phase is the prediction. So at the first, the model will give some prediction. It might be correct, it might not be correct. At that time, like seeing the percentage, like how much accurate my model is, like how much accurately it can determine whether a person will break the signal or not. I can go back to my collection of data, collect more data, and train the model again so that it can reiterate to all of those data and learn the new features and etc. And then we can do the prediction. This process goes again and again until the my desired accuracy is achieved. And also, if any new data is available, we train it so that it is much more accurate in real life situation. So, now I think you might have a brief overview like how machine learning is useful in our day-to-day life. Let's look in some of the machine learning techniques which are mostly used in the industries. So first is the major broad classification of the machine learning is supervised training and unsupervised training. So supervised training is somewhat where the data and the output both are fed to the machine learning model, and the machine learning model trains from the output which is given. Like for example, if I'm keeping a model to detect the stop sign, then I am telling the signs that this is a stop sign image, and I am telling the computer what will be the future output, so that it can train from the input as well as output itself. In the unsupervised systems, the model learns from the patterns from the unlabeled data. For example, if I just throw hundreds of images to the computer and I tell learn whatever you need from from those images, it will detect like what are the patterns of these images. Like for example, in danger signs there is always red color signs. If it is related to the walking people, there are stick figures on the signals. So it can determine the patterns from those unlabeled data, and it learns those pattern and determines the output based on its own learning. So I will be focusing more on the supervised learning part of the machine learning in this further slides. So one of the type of supervised learning is classification. Classification consists of labeling the data. Like for example, if I provide an image to the computer, it can classify whether an image is of a cat, is of a dog, is of some other person or label or etc. So these machine learning systems are useful where we have to like determine the type of objects which we are the type of object we want to specify. For example, in like if we use Snapchat filters or etc. So at that time it can classify whether like it's a face, it's a body part or etc. So at that time we use classification methods, and also whether like for example if we provide data for the students scores, and we have to classify whether a student might pass or not pass in the future. So at that time classification model helps. So that's one of the types of ML model. Second is regression. Regression is usually used for finding the trends between the data. For example, if I am giving the graph of rainfall in a region, and I need to predict the future rainfall, at that time regressions are used. Then we also use it in Google Maps, like finding the optimum path between the two places. At that time, the regression is used. So it is helpful in determining like continuous variables. For example, in a graph, the rainfall varies from time to time. At that time, it identifies the trend between the rainfalls. Like for example, in June, July, we have heavy rainfalls, and then from February, March, April, we have summer. So at that time, it is able to find the trends from those continuous data, and it is able to detect the further rainfall prediction. Another is clustering. Clustering helps us to segregate the data based on based on their features. Like for example, if we go to Flipkart and there is a list of mobiles, we can do the segregation of mobiles. Like if the RAM is greater than 3 GB, put it in high-end phones. If the RAM is lower than 2 GB, put it in low-end phones. So at in a single phone there might be hundreds of features. So at that time the classification of mobiles manually is not like possible. But if we use machine learning and use clustering of mobiles, so we can cluster the mobiles on multiple features like high-end phones, then Android phones, iOS phones, etc. So at that time the clustering machine algorithm works. It is also used in handwriting classification. For example, if you want to determine like what are the different strokes or strokes are used for a number A or number 7, etc. So at that time, clustering works. It determines the cluster in which the images of 7 are most probably there, and images of 2 are most probably. Next is the sequence prediction. Sequence prediction is the determining the like the future sequence of a user from the past sequences. For example, if we use Google typing, we might have used like swiping the keyboard feature. So from swiping the keyboard, it is able to determine which word I am going to be used in the future. Also, while writing emails on the Gmail, then you might have seen the autocomplete feature from the Gmail, where it determines whichever word is going to be next, based on the sequence of the words which you have been using in the past. For example, if I was to write sorry for the inconvenience, sorry after the word sorry for it already shows the word for inconvenience and etc. So at that time, sequence prediction models are used where the model identifies the future sequences that can be used based on the current data which is provided. The last type is style transfer. Style transfer is using the features of one input and superimposing them on the features of the second input. Like for example, you might have been using the Snapchat filters. So the filters are somewhat of a features in an image. So that those features are used to transfer those style on our images, and we can use them. Also, while using YouTube videos, we have been seeing the captions in the below. So those captions determine the voice of our voice from the video, and it superimposes the text to those voices, so that it is able to caption each of the words which we are telling during the video. So that's how style transfer machine learning models work, and it is helpful to us. So like now we have like seen some of the algorithms or some of the methods of machine learning models. So we can see some of the use cases and determine which method suits best for each of them. So first, as I told, recommending phones on Flipkart, we can classify those phones in different subsections like Android and iOS, etc. So we can use sequence prediction for recommending the phones. Like for example, a user has a history of getting the Android mobiles, and that too from let's say Samsung. So it helps us to recommend the top phones from the Samsung which are within our price budget, and also like which have been inclinated to our past history. So at that time, sequence prediction models work, and it's helpful in recommending the phones like good quality phones to the user. Another one is labeling Gmail emails as spam or promotions. You might have been seeing that there are around thousands of emails coming each day, and it has been automatically shifted to the spam or promotions folder. So at that time, if you wrote an like traditional code, like if I see a keyword from Facebook or something, you should shift the mail to a spam. That might be tedious. So at that time, machine learning model helps, and we can use the classification models for those scenarios, where the model is automatically classified based on the words which are provided in an email. Another is finding the genres of songs in Spotify. Like I like slow songs, and at times I like to hear blues or jazz or something. So at that time, we can use the clustering algorithm for determining the different clusters of songs in Spotify. And whenever a new songs come, we can assign it to a particular cluster, like and we can give the recommendation to the user based on the clusters. Then I had given the example of captions in YouTube videos. So we can use style transfer for that, where the voice of the user is superimposed by the text provided by the YouTube, and it gives the caption to the videos. And for like even for using predicting password strength, so we might be using like traditional programming for that. Like if a user has for a capital letter, a small letter, and a special character, the password strength is strong. But that too gets cracked nowadays because we use words that are close to another. Like for example, I in my college days, at the first I was using the password as my birth date. So at that times it was helping me the machine learning also helps to predict how much strong the password is based on the input of the information that I give to him. So it can be used in the form of classification and regression also. So for an brief overview, like reviewing, we came to know about what ML is, what are the traditional differences between traditional learning and machine learning, what is the necessity of ML in the new age, like the data implosion, that is the main reason for the growth of ML. Then how to implement ideas using ML. First, we have to identify the user, then define the goal, collect the data, train the model, and refining it again and again until the accuracy is achieved. Then what are the differences between AI, ML, and DL? What are the different types of machine learning? I think these points are covered. So machine learning is fine, but it's mostly algorithms and algorithms. Like for example, linear regression. You know how to write a formula for creating a line on a graph. So that's entirely based on algorithm. So we were like hoping that machine learning would be something that can like think like us, like humans. So what makes humans different from computers? Like for example, computers have their own circuit boards, have their own logic boards, but we humans have the one thing that sets us apart is the brain. So in the further part, like the deep learning, we are hoping to achieve to replicate the human brain as a system for the computer. So what basically human brain is made of? Human brain is made up of dendrites, which carry the information from neighboring cells. The nucleus, which determines what to do with those information, and then the axon, where the data is sent to the other users. So in the similar regards, if we were able to transfer it to the machine, so at that time, the dendrites would be somewhat of an input to the computer. The nucleus will be and would be an internal node for the computer, and the axon will be the output for the computer. So by this, we hope to achieve that we can replicate somewhat of a brain function to the computer by using these nodes. We also call them as neurons in some cases, in some textbook references. So perception of an artificial neuron, like what artificial neuron actually does. So it takes an input from the user, and there is an activation function. Activation function, and whenever this function is hold to be true, we send the output and then activate the new neuron. Otherwise, we don't do anything, and don't let the data to pass forward. So activation function is not such an heavy stuff. Like for example, we have to determine whether a number is greater than 5 or not. So at that time we use activation function as it is less than 10 or etc. So at that time the activation neuron is doing the yes condition, and it activates the further neuron. For example, if I provide an image for seven being and having is having a curve or not. Like for example, six has a curve, but the seven doesn't have the curve. At that time, the activation function gives no response, and the further neurons are not activated. and the information is thought of having no value. So in a similar case, if we are using 6 as an input and has a curve, it activates the neuron. So some of the activation functions which are used in like further development is one is the sigmoid function. Sigmoid function is basically this formula 1 upon 1 plus e raised to x. So the main purpose of this function, it converts any value given to them between the value of 0 to 1. So the main use of this sigmoid function is giving the probability of a value. For example, the machine learning determines whether a cat or a dog image is 50% or 90% cat. At that time, the sigmoid function is used because the probability can vary only from 0 to 1. Second is ReLU. ReLU is called as rectified linear unit. It is an activation function which is basically doing a max operation. So when once the value is less than zero, it does not activate the neuron. Otherwise, when it's greater than zero, it directly sends the data to the forward neuron. So this we saw like what one neuron can do. If we combine those multiple neurons, we can do like a large number of things. For example, from a cat or dog image, if one neuron is able to determine whether it has two eyes, then whether the cat has whiskers or not. If we are able to combine those multiple neurons, we can add those function and able to determine whether a image is of a Labrador, it's of a cat or something, etc. So combining those neurons is similar to what our brain does. Like we have millions of neurons. Those work in coordination with each other and give us the output which we do, like walking and talking, etc. So for seeing the example yourself, yeah. So I have this input information provided to me. So I have to create a machine learning model where we can where we can classify those objects. So for example, if I am using just one neuron in each of those cases, like this one is for x equals to y. It can only divide the plane in in one vertical line. So if I start training with that, the a single neuron cannot train the entire features from each of those. But if I add multiple neurons, at that time, just a minute. Yeah, if I add multiple features, you can see that slowly the machine learning model is able to determine the regions for the images. So from that, you can see that using this X and Y both, we can train the model to be to determine classify the objects. So if I include more such neurons, for example, here there are three neurons and inside there are four and two neurons. This can be used to classify it more accurately. And by doing that, by increasing more neurons, I can improve the accuracy of learning and accurately divide those clusters based on those. So this helps us to understand like using multiple by using many such neurons. Each of them neurons have their own features which they identify, and each of those features are used in classifying the object. So this is a general structure of an neural network where we provide input from one side. Each of those neurons provide their output, and each of those outputs are given to the next neurons. And each of the input which is provided from the neuron has some weight, like the information which is useful. For example, if in a model where we can determine whether image is of a cat or dog, and if a, cat's image is sorry, if there is a cat's image is provided, at that time we don't need the neurons which has information like does it have long ears, does the images have their teeth sharp or something. So at that time, some of the neurons have higher importance than others. So that's where weights come in. It gives the importance of each of those neurons. Once we carry forward the data through each of those neurons, and we get the final output, we check whether the given output is similar to the actual output which should be present at that time. Based on the difference of values which is provided, we send those data back to the network in a form of feedback, so that the importance of each of these neurons is changed based on the new features which are identified, and they are trained again and again. So this is what training consists of. We provide the data to the network. It provides the output. So once the output is provided, it is compared with the model, and then we give the feedback back to the system. So these methods are like for one dimensional. How do computers perceive two-dimensional images? Like for example, images. Images, we can know that know that it is basically a matrix of numbers for the computer, like from 0 to 255. So each of those is basically a matrix of numbers. But daily images consist of three colors like RGB. You might be knowing about the various colors schemes of an images. So that is an three-dimensional matrix. So for the simplicity of the further explanation, we are considering only black and white images, 2D images. So this is an 2D image of the text like handwriting recognition. So each of the images are shown in the format of black and white. So this comes to the next part in neural networks, that is convolutional neural networks. Convolutional neural networks consist of determining and output from input of an images. So first part is the entire process consists of convolution, then pooling, then fully connected layer and output. So this first part is the feature extraction from images, like whatever features which we want it to identify, and the last part is classification. So what is convolution? Convolution is basically using a matrix and multiplying it all over to the image so that it identifies the features. Like for example, here we can see that it identifies what are the vertical lines from the images. For example, if I have to have a demo, so you can see that the red cursor which I am showing is a matrix is multiplied by the value given in the center, and the value is stored in the side matrix. So this exact matrix is able to determine the sharp images. Then if I am using some another matrix, it is able to determine the vertical lines in an image. So these each of those function help us to determine a particular feature of the image. For example, here it is a vertical line. In some other matrix, it might be giving horizontal line, some curves, etc. So at that time, each of those convolutions help to extract those features. Second is pooling. Pooling is basically the images which the extracted features which we get from the convolution layer are used a max function. Like for example, in a matrix of 3 by 3, the maximum number is got from the images which we get from the images are sent to the pooling. So that, like for example, if a person's photo is taken and we want to highlight the features of the person, the background is not really much required. So when we do pooling, the information based on the background of those images are lost, and only the important data of the user, which is the person in the image, is carried forward in the pooling. Third is the flattening. In this flattening, we convert a two-dimensional image to a one-dimensional data. Here you can see 110421. It's basically flattened in a flat format. And after this step, it is basically an artificial neural network, which I had shown in the past. So that's how a machine learning model is able to determine from an photo. So for example, here is an demonstration for like determining the text. If I draw an image, for example, two, it is able to determine the features. Like for example, this convolution is able to determine the curves in an image. This convolution is able to determine the horizontal lines from the image, and many such features are extracted. Each of these features are extracted in the forward pooling layers, and then it is converted basically to an artificial neural network, and all the data is sent back to the last layer, which determines what is the guess of the character which I have drawn. For example, the first guess of this number is 1 and the second guess is number 2. So I can draw any like random. For example, if I am drawing in 3, it is giving the first guess as 8. So this doesn't need to be explicitly programmed for only the numbers which are provided in the system. It is helpful for determining other patterns also. So, like you might be wondering, like it is difficult for each of those coding each of those neuron. For example, in this, in each of those neuron, we have to code for each of those systems, do matrix multiplication and etc. So, but I am like a lazy person. I don't want to like create an entire thousands of lines of code just for determining a character recognition code. Like I can do it just by looking at it. Why can the computer do it? So, like if we go to the writing of the entire code, we can see that this is the entire code used for determining how whichever number is written in an image. So you can say only this around by using this 4 to 5 lines, we can create an entire machine learning model which is able to determine from an image whether a character written is of 1, 2, 3, etc. So there are nowadays many much systems like TensorFlow, then Keras, which helps us to use a short code modules, which can be used for creating large models, which are able to solve many much complex problems. So, in a brief overview, deep learning is not like creating an entire sentient robot or something. It's just using the short code scripts and able to solve complex real life problems right from our own computers. So by using this convolution neural networks and different machine learning models, we can do many tasks such as image classification, where we can classify the images based on their features. Even the government uses image classification in satellites, where from the satellite we can determine whether there is an hurricane or there is a storm in the near future. We can do many such real life applications such as object detection. Like for example, in the driverless cars like Tesla, there are object detection for determining whether a car or a person is in the forward. It can determine whether a traffic light is forward in the front or not. So the applications of machine learning and deep learning is endless, and it's entirely dependent on you guys, like how curious are in the field of in this field, and how deep you want to explore and create new systems that will be helpful for people as well as to the nature. So yeah, that's it from my slide. I hope that it was a great introduction for you guys in the field of machine learning and development of deep learning systems. Over to you, Salami.
Thank you so much, Karthik, for letting us and the community know more about machine learning and deep learning. I would now request our director, Harshada Topale, to take over the Q&A round. And for all the IIC CCPC members who are watching the webinar right now, you can log into the company platform and type in CC Assist in the search bar as shown in the screenshots. Next, you can type in your question or queries that you have for the guest speaker. You can also follow a similar procedure on the mobile application to ask your question to the guest speaker. Over to you, Harshada.
Thank you, Salome. And this was indeed a very insightful session, right? Covering right from the fundamentals to telling how the application of the technology would be. So, thank you, Karthik. I'm sure everyone must have enjoyed, and the presentation was really good. Thanks for that. So, I would start with the first question then. How what is word embedding in deep learning is the question that has been asked, Karthik.
Yeah, so word embedding is a part of NLP, that is natural language processing, in which the machine learning system works on the data which is provided in text format. So word embedding is basically we divide those words into parts. For example, if a go is an word, it has many much examples in English language like go, going, goes. Each of those words have different meanings, but at the root they are the same word. So
Yeah.
by but using those multiple words, the machine learning system might get confused. At that time, we have to break each of those words to their root words and provide the like whichever figure of speech it was used in the original case. At that time, the word embedding comes into play. So it is basically an method which we make the text more interpretable for the computer to understand.
All right. Yeah, that's yeah, and it's quite good to know. The next question that we have, Karthik, is how do you handle missing or corrupted data in the database?
There are many cases in which the data is not entirely complete, like some of the features are not complete. At that time, there are two to three methods. First is if it's an continuous variable data, like for example, it's an data on the ratings of a person given to an app or something. At that time, we fill the averages of the data. If it's an classification like data, for example, if it's a user or not data, if it's an registered user or not data in an column, at that time we fill with the mode, that is repeating the values which have been most frequently used in the data, like yes is been used in the 35% and no is around 80%. So we filled the remaining data with no, such that the general trend which is there in the data is carry forward. But if the percentage of missing values is greater, like for example, there is a column with only two filled data and around thousands of unfilled data. At that time, it's better to drop those columns or drop those rows which don't have many much meaningful data.
All right. All right. I'm sure this is going to help all the students to work on the data that they have. The next question that Karthik that we have, I mean, of course, you've explained quite a bit of fundamentals here, and how the implementation would be as well. But would you be able to tell the students some of the sites from where they can start learning ML and deep learning right from the start? So right from the basics, what I mean to say.
Yeah, so like one of the great start for the machine learning would be, I think, the course from Andrew Engine Coursera. That gives the great fundamental idea on the machine learning. Some people might be thinking it's a bit boring because it entirely play with the calculations and the theoretical part of machine learning. But for going forward in like the coding perspective of machine learning, it's great to have a conceptual clarity and a theoretical background. But once that part is completed, I would like recommend people for exploring more about TensorFlow, Keras, and other like real life application examples, blogs, and etc. One of them would be like there is also a course from Lawrence Mooney on TensorFlow developer on Coursera. Those two courses are a great start for any user.
Oh, that it's nice to know. Thank you, Karthik. I'm sure people have, I mean, the students must have made a note of this. Uh, yes, everyone, please just follow the instructions that Karthik has given, and I'm sure you'll be able to, start learning in a better way. Then, Karthik, one more question that I wanted to ask was that you have already been part of some Google AI and ML initiatives. So, would you like to share your experience with the students here?
Yeah, so in my around second year, I had applied for the Google AI Google AI initiative. I came to know about the application from LinkedIn. Like one of my fellow LinkedIn user had posted the registration form, so I applied it, and there were some basic I think interviews and some forms which were provided, which I had to fill, like how you will improve the community of our college, and how much knowledge we have currently on the machine learning. So after the selection of the program, there were some grooming sessions from the experts from Google, where we were given a brief overview, like how deep learning usually impacts on a scale where the Google operates or any MNC operates, and how it's useful. So like before like going towards the like exploring these new possibilities, first we have to gain the curiosity of the field, and gaining the new opportunities, that is entirely a different part. But the curiosity, that is very much helpful in exploring these opportunities, because like from our current curriculum in college, we are like in a limited scope of like knowing how the machine learning really impacts the society. But exploring the new things from over the websites, from the tutorials, by meeting industry professionals, that will help you in exploring this field more than anything.
Yes, I think that's precisely the reason why Cloud Counselage is also, has initiated the Cloud Counselage professional community. That's because of the gap that is there in the academy and what is required in the industry. I'm sure many people will take inspiration from your experience, Karthik. I really want to thank you for all the insights that you have given to the students today. I really appreciate that. And I would hand it over to Salome to take the session forward. Thanks, Karthik. Over to you, Salome.
Thank you, Harshada. I would like to thank the guest speaker once again. Thank you, Karthik, for taking time to speak to us today and sharing your vast experience with us. And of course, the presentation was very enlightening and comprehensive. And I'm sure the students also find this session insightful, and the knowledge you shared will definitely help the students who wish to start their career in this field. And I would also like to tell the students that this was possible because of CCPL and CCGSE coming together under the IIC CCPC initiative. IIC CCPC offers 14 benefits, as you can see on the screen, which is corporate and industry exposure, online internships, access to our corporate systems, access to free technology and management trainings, off-campus placement updates, monthly seminars or webinars, one which you're already a part of right now, CV and profile building assistance, industry visits, and also job opportunity for high performers after graduation. ICCCPC activities are year-round and not seasonal. This is one simple Gantt chart that we have prepared to help understand all the activities that are conducted over the year. So make sure you express your interest for the same on the ICCCPC page. Apart from this, we have other benefits as well, as I mentioned earlier. You can see them on the screen as well. Please note that this membership or program is completely free of cost, and there are no financial liabilities or no costs involved for the students or the academia for this initiative. We do expect 1 hour per week to be provided by the students and 4 to 5 hours per month to gain the right industry academia connect. That is all that is expected from Cloud Counselage. Next, if you are a student and want to join the community, please express your interest at cloudcounselage.com/IC-CCPC. If you're a faculty and want to associate your college with CCPL and CCGSE Foundation, please visit cloudcounselage.com/IAC. You can also reach out to us or follow us on the following social media platforms for all the latest updates and many other insightful events like these. And please take a screenshot of the same. I would like to thank the guest speaker, and I would like to call upon Kartik Raj for the parting words. Over to you, Kartik Raj.
Yeah, thank you, Salome. First of all, I want to thank Nirbhay, Salome, and the entire team of Cloud Counselage for having to me. I have been part of Cloud Counselage in my starting phase of my career, and it has been really helpful for me getting a jump start in the career because of the experiences which I gained from Cloud Counselage and the industry exposure which it provided to me. Uh, and along with that, I would like to thank for the students for taking their time and having the curiosity to explore this entire new field. And I hope that most of you get the understood the program, and it would be really good that you would explore this field in a comprehensive way in the future. Back to you, Salome. I think that's from my side. Yeah, thank you.
All right. Thank you so much, Karthik. On behalf of the entire CCPL team, I would also like to thank everyone on the team, Apurva and Harshada, and everyone on the back end for making this webinar happen so smoothly. Thank you so much.